Hey everyone, welcome back. Today we are talking about normalization in database design. How splitting data into related tables helps you reduce redundancy and improve data integrity. If you have ever wondered why we separate customers from orders or products from categories, this video is for you. So let's get started. And first, we start by what is normalization. Normalization is a process in a database design where we split data across multiple tables. Each piece of information is stored only once. The goal is to first reduce redundancy. We avoid repeating the same data in multiple places. Number two, improve data integrity, like make updates and deletions simpler and less prone to errors. Essentially, it's about organizing your tables and columns to ensure each fact is recorded only in one spot. Okay, but let's try to understand why. Why normalization? Like why we should do this. Um, there are four reasons we want to talk about. Number one, reduced in inconsistency. Like if you keep the same data in multiple places, you risk forgetting. You risk forgetting to update all copies. This is one of the things. Number two, easier maintenance, like changing or removing data in a single location affects the whole system. Number three, smaller storage footprint, like no duplication of larger text fields or repeated columns. Number four, cleaner query logic, like clearer relationships between entities like customers, orders, products, etc. So a well-normalized schema can save you headaches really down the road. It's really helpful in my opinion, especially in systems that continuously evolve. Okay, let's take an example for normalization. Okay, so imagine you have a customer database. If you place customer details like name, email, phone, etc., and also we have an order table. So if we put the customer details like name, address in the order table, you will repeat it for every order that the customer is making, which first we have redundancy because we have multiple rows stores in the same customer info. Number two, we have risk of mismatch because if you update one row but not the other, we can have some sort of inconsistencies. So instead of creating all of that, we will do something like that. We will add here. Oh no. Let me, yeah. We basically will add the customer ID here, and this customer ID will basically point to the actual customer that we're talking about. So a customer tables will, with a customer specific details like customer ID, name, and something like that, we will put the customer ID to point on it. And yeah, when an order is placed, you just link to the existing customer to avoid any duplication. And yeah, it will save you a lot of time, a lot of headaches. It's really helpful. Yeah. Okay, let's talk about some level of normalization, and we will talk about three levels. First, the 1NF, which is no repeating groups, columns, store atomic values. I'll just talk about them on high levels. I will not go deep. We might in the future create videos that talks about each one of them. The second one is 2NF. It's built on top of 1NF, like no partial dependencies, but we add on it no partial dependencies on part of a primary key. Number three, we have 3NF. It's built also on 2NF. It means like no transitive dependencies. Um, if you don't understand what's going on about this, okay, let it sink for now. We might in the future create videos to talk about what each one of them means. But I would say, in context of system design interviews, you will not need them that much. Like from my experience in system design interviews, you only been asked about normalization and denormalization. Next, we will talk about of the trade-offs and denormalization. Maybe in the next video, I will dedicate a video that only talks about denormalization. But for now, we talk about normalization. So yeah, in the trade-offs, while normalization reduces redundancy and improves data integrity, it can lead to more joins in queries. If you have extremely large data sets or certain performance requirements, you might denormalize some parts to cut down on complex queries. The key is finding a balance that meets both your integrity and performance need. Okay, I guess we can talk about some tips for effective normalization. Number one, identify entities like pinpoint distinct objects like customers, orders, products, things like that. Number two, define primary keys. Like each entity should have a unique identifier like customer ID, for example. Number three, establish relationships. Use foreign keys to link related entities instead of duplicating info. Number four, check for dependencies. Like make sure non-key columns depend on the key, the whole key, and nothing but the key. The essence of 3NF. And we will talk about this in the future. Following these steps help you keep your schema clean and maintainable. Next, we will talk about our conclusion. I guess we end here. So that's normalization in a nutshell. By splitting data into related tables, you reduce duplication and keep your data consistent. While there is no one size fits all approach, some systems do like develop 3D denormalization parts of their schema and normalization parts, like just a hybrid approach. Understanding the basics help you build a solid foundation. If you found this video helpful, please like, subscribe, and hit the notification bell. And yeah, see you guys in future videos.